Good morning, everybody. Happy Friday.
Good morning, everybody.
January 29th, 2016.
Utah.
Spokane, Washington Valley. Okay.
Good morning, Colorado.
Good morning, North Korea.
You got all.
Ryan, yeah, you lie.
So you've requested to go over some problems. Some of you said you didn't finish because you didn't understand. So here's a perfect learning opportunity. So please listen. And if you're got it and you just belong for the ride, then don't disrupt those who are trying to pay attention and learn. So if I have something like this, it's called a compound inequality, right, Grayson? Because it's two inequalities in one. And so I'm going to separate them out. Whenever I have my p in the middle or my variable in the middle, I always need to write two separate inequalities. And I know if it's in the middle, I know it's going to be an and statement. And so I'm going to go ahead and write those separately because you can see they both relate to 2p minus 3. Therefore, we have to solve in both cases. On the left side, we would add 3 to both sides and get 6 is less than 2p. We would divide by 2 and get that p is greater than 3, because I always read right to left if the variable's over there, or I can write p is greater than 3. And it's going to be an and, because we already established that. So over here, we're going to add 3 to both sides, and we're going to get 2p is less than or equal to 15. So divide by 2, and p is less than or equal to 7.5. This is an and. So now we need to graph it, and we need our 3 coordinate planes. So our 3 number lines, excuse me. So we're going to go ahead and get our number lines, and we're going to put those on there. And so let's get some blank ones here. And whoop, there it is. We have 1. 2. Okay, apparently some thought it was and some thought it wasn't. Okay, so as we continue here, our key points are 3 and 7.5. 3, 4, 5, 6, 7, 8. So I want to indicate that I understand that 7.5 is between those. So we're going to go ahead and graph those. The first one, p is greater than 3. Goes like that. All numbers are greater than 3. The other one is all numbers less than or equal to, including 7.5, because the line underneath the inequality here. Okay, when it's an and, we want to know where they're both graphed. That is the solution. So we can go ahead and look at it. Let's use a highlighter to go, are they both graphed to the left?
No.
Are they both graphed at 3?
Yes.
No, that's not, that is. So it's open circle. Are they both graphed in between?
Yes.
Yes. Okay? Are they both graphed at 7.5?
No.
Are they both graphed at 7.5?
Yes. No.
Okay, yes.
Yes.
This is because it goes through it. This is because it's closed. So we're going to include a closed circle at 7.5. We're going to shade in between because they're both there. Are they both shaded out to the right? No. So that's the answer. Okay? And if you put it back together, Grayson, that's a warning. Please pay attention. Quit talking. So if I put my p in the middle, 3 is less than p, which is less than or equal to 7.5. Doesn't that make sense? Well, what is my answer? P is between 3 and 7.5, not including 3, including 7.5. So it kind of makes sense once you look at it that way. Oh, okay. It's starting to make sense now. Cool. All right. Number 9. We have an OR this time. ORs I find to be a little simpler because they're already separated out for us.
All right.
The graphing is a little different. I know some of you are still trying to differentiate between the two, so this will be a good example to go over. So on this one, we would go ahead and subtract 3, and we get 3d is less than or equal to negative 4, divide by 3, and d is less than or equal to negative 4/3, or negative 1 1/3. Here we would subtract 2, and get 5d is greater than or equal to 10, divide by 5, and d is greater than or equal to 2. Okay, that's an OR. So now let's graph it. So we're going to bring these in. We'll just go ahead and paste it 3 times. Paste, paste, paste. Put them in place. And let's begin the race to answering the question.
What if somebody from like another state sees this and like, wow, this guy's weird.
Yeah, that's cool. It's Washington. That's entertaining. Okay, so
Yeah, from Utah. What if somebody from Utah sees this?
I don't get the Utah thing, but whatever.
I don't think anybody likes it.
Okay, please focus on what's important right now, and that's the math, not what state you like or don't like. Okay, now we're going to go ahead and graph. Negative 1 1/3 is about there, so we're going to go D is less than or equal to that is my first graph. D is greater than or equal to is my second graph. And remember when we're looking at ORs, voice crack? Yeah, I know. A little dehydrated from my workout this morning. Let me get some water.
You don't have muscle. You never talk like this when we're doing.
Okay. So now what is the solution? I combine the graphs. It's a union of the two. I combine the two. Is one or the other graphed out to the left? Yes. Okay, so that's part of the graph. Is one or the other graphed in between? No. Is one or the other graphed at 2? Is one or the other graphed to the right? Most ORs will look like that. Going out, armpits are the 2 points, and it goes out. Not always, but that's a good way to think of an OR. An and is in between. The eye patch and all that. Okay? Oh, you obviously weren't paying attention. Remember this week. Eye patch.
If Apple made a car, would it have windows?
That's funny. Okay, number 11. Since Windows is not the Apple operating system, see, those are the kind of things that you guys are supposed to be, learning outside the box thinking, right? Well, it's going to only pay dividends for you someday. Okay, so on this one like this, right, Devin? We need to separate it out into 2 because I know it's an and. So I'm going to do y plus 2 is less than or equal to. I'm going to go ahead and distribute right now, just because I can. And then I'll go ahead and simplify here. So on this one, I'm going to subtract 2 and get 2 is less than or equal to y. And over here, I'm going to simplify and get 3y and minus 6 plus 24 is plus 18. And then I'm going to have to get y alone. So if I subtract y to keep y positive, I get 2 is less than or equal to 2y plus 18. And then I subtract 18, and I get negative 16 is less than or equal to 2y. So I divide by 2, and negative 8 is less than or equal to y. Okay, so what are my 2 answers? Y is greater than or equal to 2, and y is greater than or equal to negative 8. Okay, any mistakes made there?
Oh, no.
Is that what you guys got?
Oh my God, Lauren.
Okay. So let's go ahead and graph those. Quit with the mom jokes.
No, she didn't do your mom. She did the D nut.
Well, that's even, yeah, let's not even go there. Okay. All right. So now, some of you, this is a little different graph than we've seen, so pay extra close attention. This is an and. We're looking for the intersection of where they're both graphed. Okay, and the first one, first of all, my key points are negative 8 and 2, negative 7, 6, 5, 4, 3, 2, 1, 0. Perfect. Okay, so let's go ahead and put those on here just so we have our key points. My first graph, y is greater than or equal to 2, so that's going to go out here. Second graph is y is greater than or equal to negative 8. So where are they both graphed?
Right. From 2 and beyond.
Yep, that's the final answer.
2 infinity.
2. I see what you did there.
So, wait.
2 infinity and beyond, including 2.
Don't be that kid.
Okay, and number 12.
Why is Ryan here?
5z plus 3.
Yeah, I can ask you the same.
is less than -7. Or negative 2z minus 6 is greater than -8. Okay, stay with me, guys. We're almost ready to start venturing into our the rest of the problem. Subtract 3 from both sides, so we get that right there. Divide by 5, and we get z is less than -2. Or add 6. Add 6. -2z is greater than -2. Divide by -2. Oh, I have reversed the inequality. Thanks. Draw. Okay. Plus.
I said brother.
Oh, I think it's raw.
His brother.
Which means the same thing. I know, it means the same thing.
I'm wearing one.
Well, that's a different one. Okay. TMI, let's continue, please.
It'd be TMI if I wasn't wearing one.
Okay. Okay, let's just stop right there. Okay. We're going to go -2. Okay. So let's go ahead and graph these. This is an or, so it's going to be a union of the two, right, Grayson? Killing me, Grayson. Okay, z is less than -2, or z is greater than, whoop, wrong place. Thanks, Brandon. Z is greater than 1. Okay, where are both graphs?
That's wrong, man. It's the other way.
Oh, right. Good catch. Cole, go get a piece of candy.
Yes!
Okay, whoa, that wasn't that big yet. Okay. Is one or the other graph at 1? Listen, this is really important.
No.
Is 0 or 1, is one or the other graph at 1?
No.
Is one or the other graph in this section right here? Grayson, that's the strike. Turn around, pay attention. You said you didn't understand this, so you need to pay special attention. Okay. Is one or the other graph in here? Is one or the other graph at 2?
Yes.
Yes, this one is. Is one or the other graph out here?
Well, no, it's the graphic negative.
That's the final answer.
There's not one that's graphic 2.
Stop, you're not.
Yes, there is. This one is. It goes right through it. That means it's graph.
But it's negative.
No.
Okay. So, the learning target today is to be able to finish the rest. You look at problems like this. I want you guys to look at this for a second and turn back to your Unit 1 toolkit. And I want you to find your notes on interval notation. I'm going to cut these for you. I have some fresh ones for you. So we're going to put these in.
Fresh.
I don't think I don't think I have that in there.
Yeah, I'm not seeing it. Yeah, we don't have that. Hold on.
Yeah, we don't have that.
Oh.